If you don't want to look like this guy, listen up. Welcome to day 3 of a minute of Chem every day. Today's 1.3, elemental composition of pure substances. Let's start by differentiating between molecules and compounds. A compound is something with two different elements. A molecule is a structure with at least two different atoms. The difference here is that it doesn't have to be two different elements. It could be the same. So a compound is a molecule, but a molecule isn't always a compound. So what is a pure substance? It just means that the substance is 100% one type of molecule. So you won't have water and glucose in the same one. 90% of the time, if not 100% of the time in AP Chem, you will be working with pure substances. So when we say elemental composition, we're talking about what percent of the mass is contributed by what element. We can figure this out by finding the mass contributed by an element and dividing by the total mass of the structure. For example, in water, H2O, only 11.2% of the mass is contributed to hydrogen. So you have an 11.2% hydrogen composition in water, because it's 2.016 grams divided by the 18.016 total in 1 mole of H2O. Additionally, it's important to know that for every mole of H2O, there's 2 moles of hydrogen and 1 mole of oxygen. So for every mole of your molecule, the subscript under each element, that's how many moles you will have of that element in specific. Now let's do a problem. Let's do this problem. So this says that a sample of compounds, which is one of these, containing only carbon and hydrogen, is completely combusted. So that means that it broke its bonds from this one. So that means it broke its bonds, C, H, however the structure was, they broke, right? And that left C and H, just some atoms floating around, and they binded with the oxygen around in the air. So they binded with oxygen. So what it's asking us to do is to find out how much carbon was combusted and how much hydrogen was combusted. So to do that, we have to first find the amount of moles of CO2, CO2, and the amount of moles of H2O. So let's do that. Let's write down that as the first step. So what we're going to do is 66 divided by the molar mass of CO2, which, as we know, is adding up your individual element molar mass, which is 12 from carbon, and 2 times 16, because we have 2 oxygen, and 16 is oxygen. So this is 44 over 66, which is 1.5 moles CO2. And then we have H2O. So that one is 36 divided by hydrogen is 1 gram per mole, plus the oxygen there. So that's 36 over 18. So we have 2 moles of that. Then what we do is we find out the amount of elemental moles per mole of molecule. So we know that for every mole of this, we have 1 carbon and 2 oxygen. So we need to find the carbon. So we'll multiply this 1.5 moles CO2 by the 1 carbon per mole of that. So that means we have, so this is stoichiometry, you'll do it later. So that means 1 carbon per 1 mole of that. This cancels, so we have 1.5 moles of carbon. All right, let's do the same for hydrogen. So we have 2 moles H2O times, there are 2 hydrogens per 1 mole of this molecule, times 2 moles hydrogen. And then we have this. So this is 2 moles per, so that means over H2O, 1 mole of H2O. So we cancel that, and we get 4 moles. So what we do with that is we have 1.5 and 4, right? But we can't have our ratio be a decimal. So we need to multiply this to make it a whole. So the easiest way to do that is multiply by 2 times 2. We have 3, and we have 8. So we have 3 carbons and 8 hydrogens. So the answer is D. How amazing.